Hi everyone, Miss Marsh here. So this video is going to be looking at some basic geometric objects and their notations for geometry. So this sheet will have places for you to write the definition, draw examples, just write down how you write the notation, and discuss whether it is measurable or not. The sheet will also have an a set of examples where you're going to have to fill in either the notation, the object description, or an image or a sketch. Okay, so let's begin. So to begin with, we have the lonely point. The point has no dimension, and it is just a marker of a location in space. So we're not going to write a complicated definition for each of these. We're just going to get the key ideas here because we don't have a lot of room. So it is a location in space. Has no dimensions. So what does it look like? It's a dot. And the way that we have a point is, we label a point as with a capital letter. It's important that you understand it's capital letters. It could just be a dot on its own. It could be a dot as part of a line, array, a segment. As we'll see, those are made of points. It could be the intersection of something. So sometimes it's a dot, sometimes it's just where it is in the diagram. Notation, there's not a lot of notation that comes with a point. It's basically just the capital letter. So you talk about A, or you could say point A, but the key thing is it is capital letter. And now because it doesn't have any length or width or height, it has no dimension, it's just a location, it is not measurable. So I'm just going to write no, it is not measurable. A line is essentially what happens when you put a bunch of points all together in a line. Okay. It is an infinite number of points. So there's basically if you string an infinite number of points together, you get a line, and it is going to go on forever in both directions. So I'm going to say it goes on forever in two directions. Okay, so it's really important to put the arrows at the end of the line. This is going to be straight, and we're going to put an arrow on each end. So how do we name lines in geometry? There's two ways. One way needs to identify two of the points on the line. So in order to identify them, they need letters. So I'm going to highlight a couple of the points. Now remember, there's an infinite number of points, but here's just two of them. And we can say B and C. And what you do for the notation is you write BC with a line over it. A little mini line with two arrows. It's important that you put the two arrows. Let's say that there was another point in the middle between that called D. You would not call it BDC. You still just use 2 points. But you could use any of these 2 points now. So I could also call it DC. I could call it BD. And it doesn't even need to go in any specific order. I can flip the order of the letters. It's DB would work. So I'll list one more. There's a lot. Now that I've had 3 letters, I have all these different ways I can name this line, but everybody should recognize that that's the line I'm talking about. Another way that we can sometimes name lines in geometry is with a lowercase letter that's kind of off to the side, and it's usually kind of italic or cursive. So usually it's an L or an M. So I'll put a little L there. That L is basically the name of the line. It's not a point because it's not a capital letter. So the way that you would write it is you would say line L, or whatever the letter is. Is it measurable? No. It's going on forever. How do you measure something that goes on forever? Okay. So next we have a ray. A ray is essentially if you take a line and you chop it. You chop it in half. Sometimes it's called a half line. Okay, so half of a line. It has one end point and goes on forever in one direction. So to draw one, let's just put a point. That's going to represent our end point. We can name that point. We'll go E. And pick a point where the direction is going to go. So let's say I want it to go this way. Maybe that point is F, and it's going to go through F. These, of course, are perfectly straight. It's a little wiggly on mine, but if you're making this, you could make it a lot straighter using a straight edge ruler. Okay, with the notation, you're going to need 2 points. You need to start with the end point. So you start with the end point. So we're going to start with E, and then we need another point. So my other point would be F. And then you're going to put a little ray on it, and it's always going to go to the right, no matter which direction the ray is going. I don't care. If it's going up, down, left, right, whatever, it's always the notation shows the ray going to the right. Okay, but if you try to do FE, that is wrong, because F is not the end point. Is it measurable? Nope. We still have one part that is completely going on forever, and that's not measurable. Basically, infinite things are not measurable. All right, a segment. So a segment is a part of a line that has 2 endpoints. A part of a line with 2 endpoints. It does not go on forever. It starts and stops. So let's make a picture of 2 points. Just put 2 points anywhere you want. Let's name them G and H. And you're just going to connect the dots. You're not going to go through them. You're not going to put any arrows. Just going to connect the dots. This is a segment. And for the notation, you are going to use the endpoints. Even if there are other points on it, like let's say there's a I right here, we cannot use the I because that would be talking about a different segment. So if we want the whole segment, that's going to be GH or HG. And then you can see I put a little line segment on top. I do not put any arrows on that. Okay. So this one from here to here would be GH. But if I say GI, that's from here to here. See the difference? Or IH also is in this picture. Basically in this picture, I've now created 3 segments. Is it measurable? Yes. We can measure it. It stops and starts. We can measure it. Okay. Now, these 3 that we just talked about, line, ray, and segment, they all go flat. Okay. They're essentially one-dimensional objects. So if a point is a 0-dimensional object, lines, rays, and segments are one-dimensional objects. So what about 2-dimensional objects? That's where you get a plane. It's so this is 2-dimensional. So the definition of a plane is a flat 2-dimensional surface, essentially. It goes forever, it goes on forever in all directions. So think up, right, down, left. If you're looking straight on, like a coordinate plane, you may remember from algebra. Okay, so how do you draw that? It's a flat surface. Well, if you're just drawing one plane, the way that we usually do it is we draw a parallelogram-like shape. Okay, and you can see it's but it's technically going on forever. It's like an infinite piece of paper is how I would describe it. Okay, now to name it, we need what are called 3 non-collinear points. Okay, so for our notation row for plane, we need 3 non-collinear points. Non-collinear basically means not all in a line. Okay, so if you want to add that in, not in a line. So think it would make kind of a triangle. So let's say I'll have a point here, a point here, and a point here. If they were all in a row, then there's actually an infinite number of planes that would go through those points, but there's only one plane that will go through these non-collinear points. Okay, so how do I name it? I would say, we don't have really a symbol. We would say the word plane and then ABC. You can use more letters if you wanted to. Another way that they might do it is they might have like a box, a 3-dimensional box. And then a plane, each of these faces of the box is considered a plane. And so sometimes they might have like the letters of the corners. And you can say plane A, B, C, D, and everybody would know which one you're talking about. Is it measurable? No, it's infinite. It goes on forever. You can't measure it. If we were to chop it up and turn it into a polygon, then we might be able to measure it in area. But the plane itself does go on forever. Okay, angle. We see angles and we use angles a lot in geometry. So an angle is basically when you take 2 rays that share a vertex. Oh, I should mention the initial point is where we're going to start our angle. Okay, that's going to turn into a vertex of the angle. Okay, so I guess I should say 2 rays that share an initial endpoint, and that becomes the vertex. Okay, so 2 rays that share, you can call it an endpoint or you can call it an initial point. So I'm going to put a point here and I'm going to make a ray going in this direction. Let's call this L, M. So there's 1 ray. Now I'm going to make another ray that starts also with L, goes in a different direction. Let's say LN. And so the angle itself is this measurement. How far apart are those rays? So if they're very wide, you're going to get a larger number. If they're very narrow, you're going to get a small number. And that's what we measure when we think of degrees. Okay, 1 degree, 2 degree, it gets bigger and bigger. Okay. Now naming angles, there's a variety of ways to name angles, but the most important way is to understand how to use the 3 letters. So use 3 letters that wrap around the angle, the vertex. Okay, and this is the vertex. L is the vertex. It's the corner of the angle. Okay, so you put an angle symbol. Don't worry about changing the angle symbol depending on the direction or size of the angle. That's just always the angle symbol. I don't care if it's an obtuse angle or a right angle or whatever, it's the same symbol.
And you can go in either direction. I can start with M, go to L, and then go to N.
But you see how I'm wrapping the letters around the angle, so it could be M, L, N. Or I could start with N, go to L, go to M. But you'll see in both cases, the vertex letter L is in the middle. So sometimes when you have an angle that's just all by itself, you can just call it by the vertex angle L. But so often in geometry, we have angles that are connected to other angles, and it's not really feasible to use just the vertex letter because we would all get confused. Is it measurable? Absolutely.
Basically, we're looking for how far apart are the sides of the angle. And we measure it in degrees. Although we will learn also another one, but you're used to degrees for now, and that's fine. But there are other ways. And for the segment, we use units of length. And we're obviously looking at how long it is. You could use a ruler. Sometimes you could use properties. If we're in a graph, it's different how we measure it. So just, yeah, we'll learn all that. Okay, so we have this information all filled out. Okay. The rest of this is practice. Okay, we have notation, sketch, and a description. So for our first one, we only have a description. It says a ray that begins at B and passes through C. So we're going to need to write the notation for that, and we're going to draw a sketch. Okay, so let's do this first one together. So I know it's a ray, and it tells me it begins at B. So I'm going to put a point here with B. And it passes through C. So it doesn't tell me where, we don't know that information, just somewhere, maybe here, here's C, and here it goes. There's my picture. That meets the description. And so notation, I have to remember the ray notation. I have to start with the end point or the initial point, then put the other letter, and I put a little ray on top. So I want you to go ahead and fill out the rest of this table using the information that they give you. Okay, so go ahead and pause this video, and then when you're ready, unpause it to see how you did. All right, so let's take a look at how you did. There is one blank that's a little weird at the end for angle EFG. It says unblank angle with a vertex at point F. So I chose to make it obtuse, but you could also have done acute or a right angle. Obtuse is an angle that is greater than 90 degrees, so my drawing is obtuse. But you could have made a straight angle or an acute angle. And the vertex point is F, and then FE and FG are the sides. Go ahead and pause this, and you can take a look at all the rest of them to see how you did. Keep in mind that the drawings do not need to be exact, but they need to have the key parts. So a line needs to have 2 arrows, and you need to have the letters. All right, I hope this lesson was helpful.